So I want to ask two follow-up questions and try to make Firehose, which you've so eloquently described, a little more tangible for non-technical listeners. So the first follow-up is, as I understand it, Firehose is a piece of code, a software of some kind that reorganizes data from the blockchain and makes it more easily indexed or transferable. How would you tie a bow on that?
Well, you said it right. I mean, it's more easily indexed and it's more easily transferred. It's more easily verified. So at the risk of being a little technical, right? When you have a blockchain node, it's a running program on a computer somewhere, and it has a database underneath. And what people do today is they connect through the network and they query that running program so that this running program reads in its database and outputs some data. Our model was to say, this is slow. This requires a lot of memory, a lot of CPU, a lot of SSD disks that are fast, resources, computing resources that are costly. So we said, let's be done with that because people are interested in the data. Let's separate the data from the computing needs. And so we extract it, we run the blockchain node, but the first thing we do is we output the data and put it in a file. So that's much easier to transform. Reading a file is much easier than querying a network system because it can fail, the disk can see it's much less costlier also. Loading a file, the files have been optimized like crazy. Like think S3, think the Google bucket stuff, storage there, Azure. These guys have made the cost of these things so low. A hard drive, like the cost shrinks each month. Putting that on a file flat, and there's also different grades of there's fast disks, but maybe if you don't use the data a lot, put it on a slow disk, something that is even cheaper. Like that's been optimized like crazy. And to tell you the truth, that's what's used in the data science world, like more and more. That's actually fascinating because you have these big engines like they do at Google. What people do to feed data in those big data systems, like a BigQuery or something like that, they actually write files in the storage, and that's the source where a big query is going to load and process the data files. So yeah, that was the premise. And the Firehose is a little bit of two things because it takes the node and in real time it spews out the data. So there's an aspect of it which is a stream of live data, and the Firehose sort of bridges the real-time stream and the fallback on the files, so that you don't see anything. Like you're gonna go really, really fast reading the whole history because it's reading from flat files. And at some point, poof, it flips and goes in real-time mode. And all of a sudden, you're on the edge. And what I was going to say earlier is you're on the edge and you're on the fastest edge there is because of the nature of the push streaming, right? Let's imagine you have 3 blockchain nodes and they are, in sync in different places of the world. Maybe the first guy in Taiwan sees the block and outputs and then pushes it to the client. Well, you'll have the first of the 3, one in Taiwan, one in Frankfurt, and one in Montreal. The first one to see is going to push it to you. So you're going to have the fastest, right? Everyone is racing to push you data as fast as possible. So that by design made it like an awesome streaming solution, the fastest there could be by design. So yeah, I find it fascinating. I love it because I see nowhere where something could arrive and outcompete the Firehose. Fastest, most parallelizable, the most complete data-wise. So there's no room for, beating it in a way. So that's why I'm happy that it lands in the graph so we can reach the whole world and make it the de facto solution for, reading any blockchain data. I think it's a pattern that will apply to all blockchain.